Okay, so we were given the points A, B, and C, A being 1, 3, B, 2, -1, and C, 4, 4. Our first objective is to write the equation of the line AB. Okay, so the equation of the line, we're going to use y equals mx plus b, and we're going to use just the A points for this because we can use either A points or B points, so we're going to use A. Alright, so 3 equals m, we'll figure out m in just a minute, x is 1, so we're multiplying these, and then plus b. So we need to figure out the m. M is always slope. So to find out the slope, we're going to do -1 minus 3, which is -4. -4 over 2 minus 1, which is 1. -4 over 1 equals -4. So the slope, therefore, is -4. So we have 3 equals, remember the slope, m, -4 times 1 plus b. So 3 equals -4 plus b, so finally b will equal 7. Okay, so now we have b. We need to put this back into the equation so we can get like our final equation for line AB. So we have y equals mx, which is the slope. Slope is 4, so -4x, and then plus b, and b equals 7. So we're going to do plus 7. This is the slope for the line AB. Okay, now we need to find the coordinate points for a point G that is collinear to the line AB. Collinear means on like the same line as the line that is made from A to B. It's on that line. Okay, so what's easiest to do is just to find the midpoint of AB, and then that is a point, and that is on the line. So let's do that. So midpoint formula is x2 plus x1 over 2, comma, y2 plus y1 over 2. Okay, so we have this formula right here, and we're going to put in points for A and B. So x2 plus x1, which is 1 plus 2, over 2. We have y2 plus y1, which is 3 plus -1, over 2. This brings us down to 3 over 2, comma, 2 over 2, which you could simplify even more and say it's 1.5, comma, 1. Okay, so this is our point G right here. Point G equals 1.5, comma, 1. Okay, next order of business, we are told to, here's the work, right up here. We're going to be looking straight directly at this. We were told to reflect the image about the line x equals 3, and you need to graph this. So first thing we need to do is we are supposed to graph ABC, the polygon, which is shown here, here, and here. So that's our ABC, and it tells us to graph it, or reflect it, off of the line x equals 3. And you can see very barely right here, there's little dash marks on x equals 3. So what you do is there's the line, and you count over to wherever your point is, and however many away from x equals 3 that point is, you do it right opposite. It's literally like a mirror. You're going to have it here, and you're just going to flip it right over. So we point it over, and you're going to do the same amount. So this is 1, 2 over. We're going to stay on the same line and go 1, 2 over, and there's your A prime. You're going to do that with all the points, and you'll end up with something that looks like this. That is your reflected image. Okay, next, we need to write the equation of the line AB and, write the equation of the line BC and AC. So, to do this, we're going to do just what we did for A, which is when we wrote the equation for the line AB. So remember, I'm going to just draw this real big up here. Y equals mx plus b. Alright, y, m, slope, x, and b. Okay, so BC and AC. Let's not forget the points. Our points are A, 1, 3, B, 2, -1, and C, 4, 4. Okay, so here's our points, here's our formula. Do not forget. Let me move this down. Alright, so now let's just start off with line BC. All right, so we're gonna do, hold on, let me pull up the work. Okay, so we're gonna just we'll use B for writing our y equals mx plus b. So we're gonna use the B points x and y to put them in here, right here for x and y. Okay, so BC, we're gonna have -1 equals, all right, well, since it's BC, we need to find the slope of BC first. So let's back up a few. Find the slope. The slope is y2 minus y1 over x2 minus x1. So it's 4 minus -1. That equals 5 over 4 minus 2, which is 2. So our slope is 5 over 2. Now that we know the slope, it'll be so much easier to put this all into our equation. So let's use x and y. So we have -1 equals the slope, 5 over 2, times x, which is 2, plus b. Now let's just quickly simplify this, and we turn out with -1 equals 5 plus b. And then we're going to end up with b equals -6. Okay, so now that we have b equals -6, that is not our equation. Our equation should end up looking something like that. So now we need to put this back in here. So let's keep y equals, what was our slope, m? 5 over 2. 5 over 2x, and then plus b, which is actually negative, so -6. That is our equation. Okay, so as said before, we have our equation, y equals 5 over 2x minus 6, and this is for the line BC. The next thing that we were told to do was to write the equation of the line AC. So now we're going to do AC. First off, the slope is, let's see, AC, 4 minus 3, 1 over 4 minus 1, 3, so 1 over 3. Slope is 1 over 3. So we're going to go ahead and use, let's see, which points did I use? AC, we're going to use C points. So we're going to use 4, 4. So we're going to do, it's going to be 4, which is y, equals m, which is the slope, 1 over 3, x, which is times 4, plus b. So 4 equals 4 over 3 plus b. So this makes b equal 8 over 3. Hold on a minute, let me make sure that is right. So it's going to be 4 over 1 minus 4 over 3. And this is going to be 3 times 3 is 12. Yep, 8 over 3. So b equals 8 over 3. Now we're going to put that back into our equation and back into our original equation, y equals mx plus b. So it's going to be y equals slope, which is 1/3, 1/3 x plus 8 over 3. Yes, so that is our equation of the line for AC. So we have AC here and BC here. There's our answers. Okay, next we have to find the perimeter and area using trigonometry and Heron's formula. So our perimeter, which is, so we have to find the distances of AC. Let me get the paper. We have to find distances of AC, BC, and AB. So I already did the work by using the distance formula. Distance formula is x2 minus x1 plus y2 minus y1. That's the distance formula. Put the points from AB in, put the points from AC in, and put the points from BC in, and you will get these exact calculations. So, the side, here's our triangle. It looks sort of like this. And we have A, oh boy, I don't even know, B and C. Let's just say that's it. It's not exactly. So, the side AC equals, this is the side AC is 3.16. The side AB equals 4.12. And the side CB equals 5.38. Okay, so now if we add all these up together, obviously that's this side plus this side plus this side, that is our perimeter. And our perimeter, once added all of these together, we will get 12.66. So that's the answer for the perimeter. And letter D. Okay, so that's our perimeter. But now we need to find the area using two formulas, Heron's and Trig. So Trig, the area using Trig, is area equals 1/2 AB times sine of C. Okay, so when we're looking at a triangle AC and B, really, since we use the opposite side, so this is little a, B, and C. So area is going to be 1/2 AB, so A, which is this side, CB, we're going to do, so CB equals 5.38, times B, which is this side, CA is 3.16, times sine of C. Okay, so we have area equals 1/2 5.38 times 3.16 times sine of C, which gets us also, by computing this, you get 1/2 times 5.38 times 3.16 times 0.66. And to skip forward a little bit, did the calculations, everything should be right. Area equals 5.61. Now let's see if this is at least similar, because let's see if this is similar to the area that we will get with Heron's. Heron's formula, which is S equals, or the square root of S times S minus A times S minus B times S minus C. That's Heron's formula right there. And the way you get S equals 1/2 A plus B plus C. Okay, let's see if that's at all visible. Yeah, that's great. Okay, so once we put all of our numbers in, which is using these sides, A, B, and C, and we know all of these sides by looking here, you will get, using this exact formula, you will get the area equals 6.49. Which makes these definitely, one of these is definitely right because they're so similar. Okay, so that is D. We found the perimeter and areas using Trig and Heron's formula. Now we need to find the measure of each angle of ABC. Now, let's see, this is a more time-consuming problem, but let's start with angle C. Here we have C squared equals A squared plus B squared minus 2AB, times cosine of C. Forgot to write the cosine in. Okay. So once we put in all of our numbers, you can see here, they're all in. You add, you subtract, you multiply, do all this good stuff until you get down to what your cosine of C equals. Now you're going to take this and make it the inverse. So it's going to be cosine of -1 times whatever you got here, and use a calculator to find all this out, and your final answer will be 49 degrees for C. Now I did this for the rest of A and B, angles A and B, it's all right here, and you will get your answers here. C equals 49 degrees, A 95, B and 36, and these all magically add up to 180.
Alright, so we have points A being 1, 3, B being 2, -1, and C being 4, 4. So the question asks, given a pyramid with a hexagonal base with congruent sides, with one side of the base formed AB and height of 5 meters, find the volume of the pyramid. Alright, so we know that pyramid will end up looking something like this. Alright, something like that. And the formula is 1/3 times base times height, and that equals the volume. So we know that we need the base. So we know that this segment is 4.12. So we can plug that to equation, which is V equals 1/3 times 1.12. We know it's 1.12 because we used the distance formula earlier and got 1.12 for the distance. It's all congruent. So 1.12, 1.12, 1.12, and 4.12 for each of those. All right, and then lastly, the height is 5 because it says that in the problem. So we end up with the answer. Solving that formula, we end up seeing that the volume for this is equal to 115.4. It's equal to the volume, cubic meters. Great. Okay. So the next question, it asks, given a cylinder formed by the circle characterized in problem number 1 and has a height of 13 meters, find the volume using the cylinder. So to find the volume using the cylinder, the formula would be V equal volume equals pi r squared times height. So we know that the equation would be, so earlier in the problem, we know that the circle, Emily found out that the radius is equal to 5.39. So radius. We already know the height. It gives it to us. The height is 13 meters. This is the radius. So now we can just plug it into equation. The equation would look something like this. It would be 3.14 times equal to 5.39 squared. We'll see that in this right here. Squared times 13. And again, going through that formula, that equals the volume. Going through that formula, you'll find that the answer, the volume for the cylinder would equal V equals 1,185.9 cubic meters. That's our answer for B. And then A was up here. Great. All right, next, it asks us, using the circle characterized in problem number 1, find the area of the triangle created by the tangent line to point B, point C, and Z. Basically, we already have those points right here. So B is 2, -1. C is 4, 4. And it gives us Z. Z is a new point they added. Z is equal to Z is equal to -3, -2. Great. All right, so now if we can quickly draw that, it would look something like, end up looking something like this. Something like that. Not a right triangle. So we already know if this is C, this is B, and that's Z, we already know this segment from earlier, and that would be equal to, that segment would be equal to 5.38. and you'll go through the distance formula to find this segment and also this segment. So you go to find that CB is equal to 5.38. B. All right, so the camera accidentally cut out for a second. So we found out that BZ is equal to 5.09, C and CZ is equal to 9.21. So after you find each segment, the easiest way to find the area of this triangle right here would be to use Heron's formula. So we'll start with S times the square root of S times S minus A times S minus B times S minus C. All right, and S is equal to semi-perimeter. Semi-perimeter is S is equal to 1/2 times A plus B plus C. In our case, we'll say A is Z. So we know that Z is right here, B is right here, and C is right here. So you'll use the segments, plug it into that, and you'll find out that the area for C, so this is problem C, sorry. The area for problem C is equal to 123.58 cubic meters. Cubic meters. And that is the area for this triangle. All right, D. Find the surface area of a cone formed by the circle given in part F in problem number 1 and a height of 6 meters. So we know the cone basically looks somewhat like this, something like that, kind of. We know the height. If we look at it from a two-dimensional point of view, it'll end up looking something a little bit like that, like a triangle. So the formula to find the area of this cone is S equals pi r squared plus pi r L. L is this length right here, and the radius, that's basically half of this right here. So we already know the radius because it's the circle that it gives us. The radius is 5.39. So we already know this, and we already know the height. So we can use a squared plus b squared equals c squared to figure that out. And we end up, so we'll do it really quickly, it'll be 5.39 squared plus 6 squared. And then we end up with equals 8.06. If you go through the math and unsquare it, then it'll equal 8.06. So after that, we plug everything into this formula right here. So it would be S equals 3.14 times radius 5.39 squared plus 3.14 times 5.39 times 8.06. You'll end up, your surface area, SA, will equal 227.63 cubic meters. And last question, it asks, draw and define a chord, secant, major arc, minor arc, and central angles. These are honestly very easy. A chord, actually flip the paper over. A chord in a circle, right here. It's this segment right here. It has two endpoints right here. That's a chord. Label them B, C, and A. Yeah, this is the chord. A secant is also part of a circle. It goes infinitely. It just runs. This line does not hit. It never stops. All right, a minor arc. If we look back to this right here, a minor arc is this segment right here. where it curves around slightly, right here. All right, this is the minor arc. And lastly, no, two more. Major arc, but you can guess it's this part right here, this whole section. All right, accidentally cut out one more time. So the major arc is this section right here, excluding this. So this whole area, this area right here. All right, and lastly, it's the central angle. It's this right here, this section, this space from here to here. Not this or that, this angle cut out from the circle. Yep, that's pretty much it.